Hello, Vishen. How are you? Am I audible to you? Make sure that I am audible to you and the screen is visible to you. Hello, Madhukar. Madhukar, Adarsh, welcome to the class. How are you guys? Make sure the screen is visible to you and I'm audible to you. Today will be the closing session of this electromagnetic induction. And till now, if anyone has any kind of doubt from this chapter, you can ask me. Have you reached your home for the vacation or you are currently in your school? Oh, ठीक. So no problem. Let's just get started with it. So what we are going to cover today is like yesterday I have told you about how to prepare, how to utilize these holidays. So I think so that you will be following that leads and make the most out of it of this time. So what we are going to do today, first of all, we are going to do some question based on motional EMF, the topic that we have covered in the previous session. Then induced electric field, although we have seen it, but I'm going to give a brief about it. Okay, na? About the induced electric field. Then self-inductance and inductors, and the mutual inductance will be the last topic of today's class. Okay. So let चलो start करते हैं फिर with the very first question. This. So here the question is, a metal rod is rotating about its end P. Okay. In a region of uniform transverse magnetic field of strength B, what is the value of motional EMF in the rod? ठीक है. So देखो पहले ना कीवर्ड को पकड़ना है अपने को. What is the keyword? Metal rod है, which means this is a conductor. Rotate कर रही है in a uniform transverse magnetic field. Uniform transverse means the field is going into the plane. Cross field है. Okay. What is the value of motional EMF in the rod? So suppose we will considering a cross electric field, sorry, magnetic field. Okay. And this is, let's say, the rod, which is rotating about this point, let's say point P. This P point के about this rod is rotating like this with an angular speed omega. ठीक है. This thing we have considered. This end is Q. So we will consider that the length of, consider that, consider the length of rod is L, small l. Okay. Now, when this rod start rotating, how the EMF will generate into this? EMF will generate, this motional EMF will come into the picture. We know that whenever there is a cross magnetic field or any magnetic field, and if the conductor is moving inside it with certain kind of velocity, then the electrons of that conductor experience the force, which is nothing but Lorentz magnetic force, Q into V vector cross B vector. And due to experience of this force, this road will get positively and negatively charged. Negative and positive charge will be established on the end of road. And this generation of positive and negative ends will lead to the potential difference of V plus and V minus. And this V plus minus V minus is nothing but V into V into L, BVL. In the previous session, we have seen it. Got it? Now, the actual formula, if I talk about it, what is the motional EMF? Motional EMF is nothing but about this formula I'm talking about. It's V vector cross B vector dot DL vector. Okay. V cross B dot DL is the motional EMF, the actual formula. Okay. So if you see in this case, this road is rotating, which means each and every point of this road is rotating with certain velocity. This point is also moving, this point is also moving, this point, every point is moving with certain velocity, and that velocity is nothing but the linear velocity, which we can relate as v is equals to r omega. And this velocity is always perpendicular. If you will see the velocity in this plane, in the plane of road, and the magnetic field is perpendicular to this plane, which means always this particular velocity of any point of this road is perpendicular to the magnetic field, which means V cross B will become VB only because it open as VB sine theta, and VB sine theta, theta is 90 degrees. Now sine 90 will be 1. So it is VB into DL. Okay. But if you will see, let me consider the road here only. This point is moving with certain velocity, let's say V1. This is moving with V2. This is moving with V3. Okay. You have covered the rotational dynamics in your 11th class. We know that from that chapter and from circular motion also, that the rotational speed of any object will remain constant at every point, but the linear speed will change because it will depend on the distance from the center of rotation or the axis of rotation. So that is why I've written it as V1, V2, V3, which means that each and every individual point on the road having different velocities. So there is no constant velocity. Linear velocity is not constant. So that is why we need to consider a very small element for which we will consider the linear velocity, and then we get the expression of little motional EMF or the differential motional EMF, and then we will integrate it. ठीक है? I hope you got it. अगर नहीं समझ में आया तो अब देखो करेंगे ना तब पता चलेगा. ये हमारे पास एक रोड है. अभी मैं ट्रांसवर्स मैग्नेटिक फील्ड सिर्फ ऐसे दिखा रहा हूँ. ठीक है. I am only showing the transverse magnetic field like this. This is point P. So from point P at a distance x, I have considered an element of dx length. This element. इस element का length कितना है? dx only. This dx element की velocity, let's say v. So what will be the velocity then? V is equals to r omega. R is the x because the distance from the axis of rotation is x of this dx element. So it will become x into omega. Got it? If you talk about the motional EMF, it would be very less because the element is very small. So we will say that dE is equals to minus, sorry, dE is equals to BVL. BVL means B is constant, V is the velocity, and L is nothing but dx. L is the length of the element that we have considered. So if you put the value of V here, it will become dE is equals to Bx omega dx. Now B and omega are constant. We can take it common. So total EMF will become integration of D, which is nothing but integration of B omega x dx. 0 to L. X can vary from 0 to L. To the entire length of the road. So motional EMF here will be this integration will lead to x square by 2. If you put the limit, it will become L square by 2. Okay. So it is 1 by 2 b omega L square. This is the motional EMF in a rotating rod. Clear है? देखो. Now what I'm going to tell you is very important. Okay. Please pay attention to that only. Okay. चलो. Let me just a second. हाँ. So what I'm going to tell you is that we can convert this rod as a battery. You're supposing that what I'm talking about. Yes, we can do that. Because if you will see, this rod is rotating in a magnetic field, and due to the rotation of this particular conducting rod, the EMF is generated. Okay, and there is a development of potential difference across the rod. Okay. So can we say that if you will see which end going to be positive and which end going to be negative, this is the rod which is moving. Okay, when the B is inside, everything is sorted out with the help of direction. So you must practice how to determine the directions in these chapters. Okay, because the chapters in these chapters, direction play very vital role. Okay. Now V is up, V is always up. Okay, V and B are always perpendicular. So if you will see the direction of V, this is V vector K, along you will place your thumb and your palm should be facing the another vector which is B. So B cross V, the thumb will tell you the direction of Lorentz magnetic force. But as I said you that for electron, if the magnetic Lorentz force is acting in this way, electron will be accelerated in the another this way. So this end going to be negative, this end going to be positive. Okay, clear? Always remember this end के about अगर क्लॉकवाइज मोशन हो रहा है, then जिस एंड के अबाउट रोड रोटेट कर रही है, दैट एंड विल बी नेगेटिव if the let's say if the motion is in एंटी क्लॉकवाइज सेंस, सॉरी एंटी क्लॉकवाइज सेंस में मोशन है, so this end would be positive and other end would be negative. ठीक है, एंड वाइस वर्सा. ठीक है, देखो जैसे ये वाला एंटी क्लॉकवाइज मोशन है, so the point about which the road is rotating is coming out as positive. ठीक है, so we can consider this as like this. This is the positive terminal of the battery and this is the negative terminal. We can consider this as also. Okay, and the EMF is here is nothing but 1 by 2 B omega L square. This EMF is nothing but the potential difference. Okay, do not confuse with it. This is positive and this is negative. Clear है? कर लोगे? ऐसे क्वेश्चन पूछ लेता है, ठीक है ना? वेरी इंपॉर्टेंट क्वेश्चन. अब इसे बात करते हैं. कैलकुलेट द पोटेंशियल डिफरेंस बिटवीन एक्सल एंड रिम ऑफ अ व्हील. ठीक है, एक व्हील है अपने पास. इफ रिम एंड स्पोक्स ऑफ द व्हील आर कंडक्टिंग. ठीक है, तो देखो यही वाला कॉन्सेप्ट हम यूज करेंगे इसी में. ठीक है, मेरे पास एक व्हील है. आई हैव अ व्हील which is not so circular but you can suppose it. This axis of rotation is termed as axle. चलो व्हील के बारे में ही बता देता हूँ. This is axle. This outer periphery which not include the rubber tire. ठीक है, this is nothing but the rim. इसे हम क्या बोलते हैं? रिम बोलते हैं. And the forks, the conducting or the road type of very small cylindrical rod are connecting is termed as spokes. ठीक है, तो इन्हें हम क्या बोलते हैं? spokes. Okay, so this particular wheel is rotating in a magnetic field. ठीक है, वो यहाँ पे मिस है, but I am telling you this wheel, this particular wheel is rotating about its axle. Axle के about ही rotate करता है हमेशा in a transverse magnetic field. ठीक है, तो ट्रांसवर्स मैग्नेटिक फील्ड है जिसमें ये व्हील हमारा रोटेट कर रहा है। क्लियर है? आप देखो, अभी तो हमने बात की थी कि जब भी कोई रोड, वेन एवर द रोड इज स्टार्ट रोटेटिंग, क्लियर है, अभी रोड रोटेट कर रही थी, तो पोटेंशियल डिफरेंस कितना आ रहा था? 1/2 ओमेगा एल स्क्वायर। ठीक है, so if you will see in this case, दिस पर्टिकुलर स्पोक को अगर आप पिक करो, कोई भी पर्टिकुलर स्पोक को पिक कर लो आप, दिस स्पोक इज रोटेटिंग विद सम सर्टेन काइंड ऑफ वेलोसिटी। ठीक है, with the same velocity about which this wheel is rotating about the axis of rotation। ठीक है, let's say ओमेगा। सो अगर एक रिम को मैं बात करूं, सिर्फ एक स्पोक की बात करूं, दिस इज अ पर्टिकुलर स्पोक which is moving with certain velocity, can we consider it as a small rod, cylindrical rod? Yes, we can. And I show you that if the rotation is anti-clockwise, so this particular end about which it is taking a rotation is positive, and the farthest end is negative. I have told you. So can we convert this whole wheel like this? कर सकते हैं? ठीक है, एनी डाउट इन दिस? जितने भी स्पोक्स हैं सबको ऐसे कर लिया। अब हमें क्या निकालना है? ओनली कैलकुलेट द पोटेंशियल डिफरेंस बिटवीन एक्सल, यानी कि दिस पॉइंट टू दिस पर्टिकुलर पॉइंट रिम पे। तो उसके लिए किसी भी एक पर्टिकुलर स्पोक को आप ले लो। ठीक है, सो द पोटेंशियल डिफरेंस बिटवीन एक्सल एंड रिम इज नथिंग बट वी ए माइनस वी आर। वो एक के लिए कितना होगा? 1/2 टाइम्स ओमेगा बी ओमेगा एल स्क्वायर। ये तो था ना, 1/2 b omega l square. Now, if you see this potential difference, it is independent of number of spokes। Number of spokes की तो कहीं भी बात नहीं होगी। Which means if infinite spokes are present, or if only one spoke are present in the wheel, it is not going to make any difference. Clear? So the potential difference between the axle and the rim is independent of the number of spokes. So suppose if we attach infinite number of rods, infinite number of spokes, ठीक है, if we add infinite spokes in the wheel, so ऐसे ऐसे मैं ऐड करूंगा एक्सेल से infinite number, so if you will see, it is nothing but forming a disk। Will it not form a disk? Yes, absolutely. So it will form a disk, and that disk is nothing but called as Faraday's disk। ठीक है, Faraday's disk। ठीक है, और इसका पोटेंशियल डिफरेंस कितना होगा? ईएमएफ कितनी होगी इसमें? मोशनल ईएमएफ विल बी 1/2 ओमेगा बी ओमेगा एल स्क्वायर। क्लियर है? सो अगर ऐसा क्वेश्चन आए कि देर आर टू व्हील्स, in one wheel there are number of spokes are 100, and in the another wheel number of spokes are 1000, so which wheel is having more potential difference between axle and rim? So what should be your answer? What should be the potential difference between the axle and rim are same because it is independent of number of spokes. ठीक है, क्लियर है? चलो अब ये करते हैं, थोड़ा अच्छा क्वेश्चन है, ट्राई टू समराइज इट। देखो इसे दो मेथड से बताऊंगा मैं। ट्राई टू सोल्व इट विद टू मेथड, ठीक है ना? दो मेथड से इसे सॉल्यूशन आपको बताऊंगा मैं। पहले क्वेश्चन पढ़ते हैं क्या है। अ कंडक्टिंग रोड ए बी इज बेंट इन द फॉर्म ऑफ सेमी सर्कुलर डिस्क, ठीक है, सेमी सर्कुलर, सेमी सर्कुलर of radius r, and it is kept in a region of uniform magnetic field such that the plane of a semicircle is perpendicular to the magnetic field, ठीक है। This rod is being moved with a constant speed v perpendicular to AB, and AB is the length. Find the EMF developed between the ends, ठीक है। देखो मैंने जो फील्ड कंसिडर किया है दैट इज ट्रांसवर्स इनटू द प्लेन, और इसी पर्टिकुलर प्लेन में मेरी जो पहले रोड थी, ये मेरे पास एक रोड थी ए बी ऑफ लेंथ एल, ठीक है, एंड मैंने इसे ही बेंड कर दिया है। आई हैव बेंड इट इन द फॉर्म ऑफ अ सेमी सर्कल, ठीक है, क्लियर है? लेट मी यूज अनदर कलर। ये मेरे पास एक बेंड की ओर, यही सेम मैंने बेंड कर दिया इन द फॉर्म ऑफ अ सेमी सर्कल। सो दिस लेंथ वुड बी व्हाट? Semicircle is radius r, so this is the diameter of semicircle, which is 2r, and this is end A and this is end B. The velocity is perpendicular to the constant speed v perpendicular to AB. So AB को लाइन, ये वाली लाइन है, इसके perpendicular velocity v is given to this point, ठीक है। So what we will do, we will consider a point from this at this length, ठीक है। dx एलिमेंट कंसिडर करेंगे इसमें, because each and every point has a different velocity. ये वाला पोर्शन v से मूव कर रहा है, बट this portion is like this and velocity is like this, so it is not perpendicular to the length. And when we are discussing the motional EMF, I have told you that this b, v and l three are mutually perpendicular to each other, ठीक है। So what we will do, we have considered a very small section of length dx, got it, and this radius is r, and let's say the velocity, this angle is phi here, ठीक है। Now I'm just considering this length only, this particular length element, which is dx, okay, dx, क्लियर? इसी पे मैं पहले जस्ट अ सेकेंड, ये मेरा थोड़ा बड़ा बनाते हैं इसे। नाउ द वेलोसिटी इज लाइक दिस in this direction, this is v, and this particular angle is phi. Phi angle पे we have considered it, got it? So what should be this angle? If you just extend it from here, if you will see along the length, we need to resolve the velocity, ठीक है। The length is in this direction, which is dx. So along the length you need to resolve the velocity. If this angle is phi, this angle would be phi, so this velocity will become v cos phi, and this velocity will become v sin phi, got it? Now we need to take only this velocity because this is the perpendicular velocity because of which the motional EMF will generate. And if you consider the very small sections at each and every point, so same will be the procedure to do that. So if you want to write the motional EMF of this part only, it would be very small. DE is equals to BVL, and V is nothing but V sine phi into L is DX. Got it? Clear है सभी को? Now, can we convert this DL in terms of phi? Because this very small angle this arc is making, this DX arc is making, this particular angle is D phi. This length is DX. So we can say according to the formula, angle is equals to arc upon radius. So DX is nothing but R into D phi. So put it here, D is equals to B V sin phi R D phi. ठीक है? B V R are constant, so we can take it common. B V R. Now only sin phi D phi will be remaining. Just integrate it to get the total EMF. So it will be E is equals to B V R. Integration of sin phi D phi will become sin pi का differentiation will cos phi positive. So here the integration will be minus cos phi. And phi is varying from 0 to pi only. So it is 0 to pi. When cos pi is minus 1, cos 0 is 1 only. So it will become BVR minus cos pi plus cos 0. Because this minus will multiply into this minus and it will become plus. Okay. This cos pi is already minus 1. So minus into minus will become plus. Plus 1 plus cos 0 is also plus 1. So it will become 2. So here it will be 2B VR. This is the motional EMF of this particular rod. Okay. We can also, can I just write it like B V into 2R? Yes, obviously I can write it like this. ठीक है? BV into 2R. देखो, what I am trying to teach you, देखो यहां से हमने पूरा एक थोड़ा लॉन्ग मेथड है, but now I am going to tell you the concept of effective length. Effective length. Concept of effective length, what it will be? Like this is a particular length, okay, from A to B. We know that the EMF is nothing but V vector cross B vector dot D. Okay. And let's say this is moving with certain velocity V in any random direction. Now, if I consider a very small element DL here, ठीक है, at each and every section, कहीं पे भी मैं consider करूँ अगर DL. So what I find out, if I resolve this particular velocity, so only this component, which is V perpendicular, this V perpendicular is only responsible for the motional EMF. Okay. If you will consider this as a section, so here only V perpendicular. So if you will see this V perpendicular, it's same for everything. This is V, then again the V perpendicular is in this direction. So what I will do, I will just connect to this point A to point B. अगर आप देखो ध्यान से, this particular conductor of random shape, ठीक है, इसके हर एक एलिमेंट डीएल एलिमेंट पे मोशनल ईएमएफ जनरेशन का कारण सिर्फ और सिर्फ वी परपेंडिकुलर है. ठीक है. सो व्हाट आई विल डू, यहाँ पे जो एक कॉमन वेलोसिटी वी थी, अगर इसे मैं इस लाइन के अबाउट ही परपेंडिकुलरली रिजोल्व कर लूं इनटू टू कंपोनेंट, देन ओनली द वी परपेंडिकुलर इज रेस्पॉन्सिबल फॉर द मोशनल ईएमएफ जनरेशन. एंड व्हाट आई एम सीइंग हियर, अगर मैं यहाँ पे एक डीएल एलिमेंट ले रहा हूँ तब भी मेरी जो वी परपेंडिकुलर है इसी डायरेक्शन में. अगर मैं यहाँ पे कोई वी कोई स्मॉल एलिमेंट ले रहा हूं, तब भी मेरी वी परपेंडिकुलर इसी डायरेक्शन में है. सो इफ आई सी एज अ होल, वी परपेंडिकुलर इज लाइक दिस. ठीक है. सो व्हाट आई विल डू, आई विल जस्ट कनेक्ट दीज टू पॉइंट्स. ठीक है. सो दिस पर्टिकुलर ईएमएफ about this curved conductor is same as if I just connect it with an imaginary conductor of straight line like this. So whatever the EMF of this E curved we are having, it is same as E effective. So E effective is nothing but, ठीक है, V vector cross B vector integration of dl, and this integration of dl vector is nothing but the connection of points, the distance between, or the displacement vector. It is nothing but the displacement vector. Displacement vector. This is integration of d. डिस्प्लेसमेंट वेक्टर से ज्यादा घबराना नहीं है. व्हाट यू विल हैव टू डू, अगर आपके पास कोई भी पर्टिकुलर लेंथ है, ठीक है, कैसी भी शेप है उसकी, आर्बिट्री शेप, व्हाट यू हैव टू डू, यू जस्ट नीड टू कनेक्ट द एंड पॉइंट. ठीक है. एंड दैट पर्टिकुलर लेंथ यू हैव टू टेकन इनटू कंसिडरेशन. ठीक है. अब देखो, इसके बारे में बाद में बात करेंगे. अभी यहाँ पे देखो आप, नाउ यू विल सी कि ये वाला क्वेश्चन कितना आसान हो जाएगा. हमारे पास ये पर्टिकुलर रोड, एक रोड थी जिसे मैंने एक सेमी सर्कल में बेंड कर दिया था. मैग्नेटिक फील्ड इज इनसाइड. सो ये भी तो एक कर्ड ही है. व्हाट वी विल डू, आई विल जस्ट कनेक्ट दीज टू पॉइंट्स. व्हाट इज दिस लेंथ, इफेक्टिव लेंथ. इफेक्टिव लेंथ इज कमिंग आउट एज 2r. सो वी कैन से दैट डी इज इक्वल टू, नॉट ई, डी सीधा लिखो, ई. ई इज नथिंग बट बी वी एल इफेक्टिव. बट कंडीशन क्या है कि V जो है ना, वो L इफेक्टिव के परपेंडिकुलर होने चाहिए. ठीक है. सो एदर यू विल सी बी वी इंटू 2r. देखो इससे कितना आसान हो गया. सेम रिजल्ट वी आर हैविंग. गॉट इट. सो ऑलवेज रिमेंबर, मोशनल ईएमएफ B V परपेंडिकुलर इंटू L, या तो ऐसे ले लो, या फिर E B V L इफेक्टिव. ये दोनों फॉर्मूला याद है. अब देखो, अगर मेरे पास एक रोड है और वो रोड इस तरह से बनी हुई है, ठीक है, and this is rotating about this point P. Magnetic field is transverse inside. Now what will we do? What is the motional EMF? So we can replace this entire length. What we will do? Just connect these 2 points. So we will replace this entire length by this length. And what will be this length? Root 2 times of L. So here the effective length would be root 2L. And you can see also at each and every point the velocity is perpendicular. Clear? देखो कितना कमाल का कॉन्सेप्ट है. ठीक है. सो इसे ट्राई करना इन द क्वेश्चंस. नाउ वी विल सी द इंड्यूस इलेक्ट्रिक फील्ड. अब देखो, जो भी फील्ड हमारे पास आई थी, हमने इन द प्रीवियस सेशन वी हैव टॉक्ड अबाउट इट. व्हाटएवर द फील्ड वी हैव कंसीडर्ड is by changing of that field. Okay na? So we have seen that a changing magnetic field induces an electric field. Okay. So suppose मेरे पास we have a transverse electric field here, transverse magnetic field, sorry, which is time varying. Got it? Due to this, there is a particular loop here, conducting loop we are taking, because this is time varying. It is not dependent. It is sorry, it is dependent on time. So there is a development of current into this loop, and this current is, let's say, I. Okay. अब I कैसे फ्लो हो रहा होगा? करंट इज फ्लो ड्यू टू द पोटेंशियल डिफरेंस. पोटेंशियल डिफरेंस इज ड्यू टू द इलेक्ट्रिक फील्ड ओनली. ठीक है. सो व्हाट वी विल डू, यहाँ पे फर्स्ट ऑफ ऑल अगर ये मैग्नेटिक फील्ड इंक्रीज हो रही है, देन व्हाट विल बी द डायरेक्शन ऑफ करंट, यू विल टेल मी. व्हाट विल बी द डायरेक्शन ऑफ करंट? देखो, अगर दिस मैग्नेटिक फील्ड इज इंक्रीजिंग, so this current will generate a magnetic field in such a way that it will oppose the increment of it. So when we curl our finger in the direction anti-clockwise sense, so magnetic field, induced magnetic field is coming out as outward. So the direction of current will be anti-clockwise. Okay. So what we will do, we will consider a very small segment of it, dl. Okay. क्लियर है? अब देखो यहां से what what we can conclude here is work done. In the previous session, I have talked about that this induced electric field is nothing but, is this induced current is nothing but because of the work done to conserve the energy. Okay. So the work done here, we will say, let the charge is moving, a charge, particular charge is moving in in this particular rod, Q node. So it will be Q node into epsilon. Epsilon is the induced EMF. Okay. Same as we have done in the potential difference chapter, work is equals to QV. Okay. So V is the induced EMF in this. So that is why we have written it here. Now this is equation number 1. We know the work done is also written as F dot dl, F vector dot dl vector, force into displacement. So can we compare these two? Yes, we can. So it is Q naught E is equals to integration of F dot dl. अब देखो, इस पर्टिकुलर क्यू नोट चार्ज पे कितना फोर्स लग रहा होगा? तो फोर्स इन द इलेक्ट्रिक फील्ड इज नथिंग बट क्यू नॉट इंटू ई वेक्टर. ओके, we can put it here. It is q naught into E dot d. This q naught and q naught will cancel out. So you can see here the induced EMF will result in the generation of electric field into that particular conductor. Got it? क्लियर है? अब देखो, एक फॉर्मूला तो ये हो गया. दूसरा फॉर्मूला कैसे कर सकते हैं? यहाँ पे इंड्यूस ईएमएफ कैसे देते हैं? ईएमएफ इंड्यूस इज नथिंग बट माइनस डी फाइव बाई डी टी, चेंज इन फ्लक्स ओवर टाइम. माइनस डी फाइव बाई डी टी इज इक्वल्स टू इंटीग्रेशन, क्लोज इंटीग्रल ऑफ ई वेक्टर डॉट डीएल. बहुत इंपॉर्टेंट फॉर्मूला है, लर्न इट. ठीक है. तो देखो, बाय द चेंज ऑफ मैग्नेटिक फ्लक्स, which is the change of magnetic field, will leads to the generation of electric field. But here if you will see, this particular electric field is making a closed curve. Closed curve. ये जो इलेक्ट्रिक फील्ड है और जो इलेक्ट्रिक फील्ड वी हैव स्टडीड इन द फर्स्ट चैप्टर, दिस आर टोटली डिफरेंट फील्ड. ठीक है. सो इफ यू विल सी हियर, electric field will be along this line. Each and every point पे electric field will be like this, tangential to this field. So it is making a closed loop. But the electric field that we have studied in the electrostatic chapter, it is not making a closed. Okay? Because that electric field will be generated by the charge itself, and this electric field will be generated by the changing magnetic field. So यहाँ पे आप नोट करके रख सकते हैं. नोट is that इंड्यूस इलेक्ट्रिक फील्ड, ठीक है, मेक्स क्लोज लूप, ठीक है, विच इज एब्सेंट इन द केस ऑफ इलेक्ट्रोस्टैटिक इलेक्ट्रिक, ठीक है। नाउ चलो, अब इसके बारे में बात करते हैं, सेल्फ इंडक्टेंस के बारे में। देखो, इंडक्टेंस इज द प्रॉपर्टी, आपने अभी तक हम इंडक्शन के बारे में ही बात कर रहे थे, इलेक्ट्रोमैग्नेटिक इंडक्शन, ठीक है। गिव मी अ सेकंड। ठीक है, so due to some changing field, whatever the field it is, due to the change of that field, there is some property, there is some EMF induced around the coils, and that induced EMF is nothing but the induction process of electromagnetic induction. So electromagnetic induction का जो point of evolution है, is because of change. So a changing magnetic field will leads to the induction properties. Okay. Now, what is self-inductance? So suppose we have a coil. Suppose we are having a coil, a current carrying coil. Okay. But what we will see ki the current that is flowing through that coil is start changing with time. So if it start changing with time, then the property associated with the current will also start change. If current is changing, which means somehow the magnetic flux is also changing, because we have seen that the magnetic field will depends on the value of current according to Biot-Savart law. ठीक है, B is equals to mu naught upon 4 pi I into dl vector cross r vector divided by r cube. I hope you remember that formula, which means कि this particular magnetic field will depends on the strength of current itself completely. So when the current is start changing, the magnetic field will start also changing. If the magnetic field is changing, then the magnetic flux associated to that field also start changing. If the magnetic field start changing, sorry, magnetic flux start change, which means there is a induced EMF in that particular coil, or there is a kind of induction in that coil. But this induction is happening because of self nature in itself only, inside the loop only. So that is why it is termed as self-inductance. So self-inductance is the property of a coil by which induced EMF is developed in itself due to change in the strength of current flowing through the coil itself. ठीक है, तो जब खुद में ही चेंज हो रहा है ना, उसी की वजह से सेल्फ इंडक्टेंस। जब इसके सेल्फ इंडक्टेंस की वजह से किसी दूसरे कोयल में ईएमएफ इंड्यूस हो जाएगा, तो वो से बोलते हैं म्यूचुअल इंडक्टेंस। दोनों आसपास है, म्यूचुअली एक दूसरे के पास है, इसके चेंज की वजह से उसमें भी चेंज हो गया, ठीक है। इफ द चेंज हैपेंस टू वन, द चेंज स्टार्ट हैपनिंग इन द अदर आल्सो, then this particular induction is mutual induction. Very simple definition, no high five. So we can see here ki how this induction is possible. It's possible because of the change in current. Okay. So we can say that the whatever the magnetic flux associated with it is directly dependent on the value of current. Okay. So phi is directly proportional to I. If you remove this proportionality constant, it will become Li. Phi is equals to Li. Phi is the magnetic flux due to self-inductance. This L is nothing but the self-inductance of the coil. Okay. And it definitely depends on the geometry of coil. So magnetic flux passing through this particular rectangular loop and magnetic flux passing through this circular loop is completely different, because magnetic flux is a property of area and angle. So area is nothing but depends on the shape, and shape is nothing but the geometry. So it depends on the geometry of coil. Okay, clear? So this particular object that you are seeing in front of you is termed as inductor. So same as we have studied capacitors. So what is the role and function of capacitor? Capacitors are used to store electrical energy. Okay, electrical potential energy in the form of charge. In similar way, this inductor is used to store magnetic field inside of it. ठीक है, अब देखो कैसे ये करता है. ये हमारी पर्टिकुलर कॉइल है जिसमें करंट फ्लो कर रहा है इन दिस डायरेक्शन. So if the current in the coil start varying with time, then the flux with time, and it will lead to the EMF induction in the coil. So epsilon is equals to minus d phi by dt, which is equals to minus of d by dt into Li, because phi is nothing but Li from the previous speech. L is constant for every coil. Sorry, not for every, for individual coil. Minus L di by dt. So now this self induction, this is for self inductance. ठीक है, माइनस एल इंटू डी आई बाई डी. ये आपको याद रखना है. ये हमारे पास एक लॉन्ग सोलेनोइड है जिसके लूप का जो रेडियस है वो स्मॉल आ रहा है. ये क्या है, जैसे स्प्रिंग होता है ना, सेम प्रॉपर्टी वही है. लेंथ एल है इसकी, और एन यहाँ पे क्या है, नंबर ऑफ टर्न्स पर यूनिट लेंथ. ठीक है, नंबर ऑफ टर्न्स पर यूनिट लेंथ. सो बी हमें पता है सोलेनोइड में, फ्रॉम द प्रीवियस केस और द प्रीवियस चैप्टर वी हैव लर्न व्हाट इज द डेवलपमेंट ऑफ मैग्नेटिक फील्ड इनसाइड ऑफ अ सोलेनोइड. इट म्यू नॉट एन आई. ठीक है, म्यू नॉट इनटू एन आई. नाउ द मैग्नेटिक फ्लक्स through the length L only. So length L का we can consider it as a cylinder in which n turns are there per unit length. The length is L. ठीक है, clear? So magnetic flux through single loop is what? B into A. Phi is equals to B. But how many loop, how many turns are there in length L? There are n turns per unit length. So if you multiply this length with n, you will get the total number of turns, and through that only the magnetic flux is passing through. So the total magnetic flux will be n into L, B into A. ठीक है, अब देखो B की वैल्यू रख देंगे म्यू नॉट एन आई पाई आर स्क्वायर. पाई आर स्क्वायर इज द वैल्यू ऑफ A बिकॉज द रेडियस इज स्मॉल r. सो हियर द फाई फ्लक्स, ये कौन सा है, सेल्फ इंडक्टेंस है. सो फ्लक्स हियर इज म्यू नॉट एन स्क्वायर A into I. ठीक है. नाउ व्हाट इज द पोटेंशियल डिफरेंस अक्रॉस एन इंडक्टर, ये हम नेक्स्ट पेज पे डिस्कस करेंगे. ये फ्लक्स एसोसिएटेड विद द लॉन्ग सोलेनोइड. ठीक है. नाउ पोटेंशियल डिफरेंस अक्रॉस द इंडक्टर. तो इस केस में क्या होगा, देयर आर सेवरल केसेस हियर. फर्स्ट केस इज आई हैव नॉट डिस्कस्ड. फर्स्ट केस क्या होगा, व्हेन करंट इज कांस्टेंट. तो ये सब फिनोमेना ही प्लेस तब ले रहा है तब करंट की वैल्यू चेंज हो रही है. तो व्हेन करंट इज कांस्टेंट, सो मेरे पास जो फाई है, सॉरी, या फाई इज एल आई, and Li will be a constant quantity. So the potential difference across an inductor, which is nothing but the EMF induction, EMF induced, is minus d phi by dt minus L di by dt. We have seen it in the previous session, previous case. This minus L into di by dt. Now this di by dt will be zero because I is constant. This phi is totally constant. So here the potential difference between the point A and B will be zero, which means the potential of point A is exactly equals to the potential of point B. Clear? Now the second case, or you can say the actual first case, is that when constant current is flowing through the inductor, ये मैंने यहाँ पे भी डिस्कस किया है. Second case is that when current is increasing, अब करंट इंक्रीज कर रहा है तो di by dt, the rate of change of current with time is positive because it is increasing. So this EMF will also be positive, EAB, let's say from A to B. So LDI by dt will also positive, VAB will also positive, which means VA is greater than VB. Got it? So potential at this end will be greater than potential at this end. So current will be flowing into this direction from higher potential to lower potential. Now, the third case you can see when the current is di by dt is negative. Di by dt is negative. So in this case, VA is less than VB. The direction of current will be opposite. Okay, the simple cases. Now if you try to solve this question only, देखो यहाँ पे एक रेसिस्टेंस है 2 ओम का. वी हैव टू फाइंड आउट व्हाट इज द पोटेंशियल डिफरेंस VAB across this line. ठीक है, so it is nothing but VA minus VB, but there are several component, electrical component here. ठीक है, so we need to find out what is the potential difference across it. So it will be potential drop of 2 into 2, V is equals to IR. So when we are moving from VA to VB, there is a drop into this resistance only, which is IR. I into 2, R is 2 also. You are getting with minus negative end of the battery, so minus 3 volt. Plus, now the EMF induced in this particular inductor is given by L di by dt. Clear? So if di by dt is positive, देखो 0.5, so it will be 0.5. L की वैल्यू आप पुट कर दोगे 2, तो यहां से आपके पास V भी आ जाएगा उस केस में. सेकेंडली, व्हेन यू पुट द वैल्यू ऑफ di by dt एज नेगेटिव, उस केस में भी आपके पास वैल्यू ऑफ करंट आ जाएगी. ठीक है, क्लियर है? किसी को कोई डाउट है इसमें? इफ एनीवन हैज एनी काइंड ऑफ डाउट, यू आर फ्री टू आस्क. किसी को कोई डाउट है? एनी काइंड ऑफ डाउट गाइस? चलो, so I have launched a poll. Please do participate in the poll to get your attendance. Now the next topic is energy stored and energy density inside the inductor on. So energy is stored in the form of magnetic field. I have already told you. So how can we derive it? Power is nothing but voltage into current, V into I. Now V is induced EMF, so it will be converted at L di by dt. If you take the power, power is nothing but the rate of work done, which is dw by dt. We can write it as. So it equals to L di by dt into I. Now dt and dt will cancel. Integration of dw is Li di. I di will become I square by 2. So the potential energy is stored in the in the form of magnetic field inside the inductor is half Li square. Now this is kind of not relevance to us, not useful to us. Why? Because every time we need to ask what is the length of conductor. Okay. But what if we try to calculate the field in such a way it is independent of the length? So for that, we already calculated it here is energy density. So energy density is nothing but energy per unit volume. So you do not need to consider the length and all. So it is directly given as b square by 2 mu naught. Okay, b square by 2 mu naught, and it is potential energy per unit volume u by a into L. Okay. Now the last topic of today's class is mutual inductance. So I have told you the phenomena by which the induced EMF and induced EMF is produced in one coil due to the change in strength of current into another coil. सो करंट किसी कॉइल में चेंज हुआ, इंड्यूस ईएमएफ किसी कॉइल में बनी, तो दैट पर्टिकुलर काइंड ऑफ इंडक्टेंस इज म्यूचुअल इंडक्टेंस। सो देखो जैसे यहाँ पे रेट ऑफ चेंज आई वन चेंज हुआ, आई वन इज चेंजिंग, so due to the change of I1, magnetic flux will change in this loop only. But the magnetic field lines passing through this loop will also getting changed if this I1 is changing. So due to the change of magnetic field, इस loop में भी क्या आ जाएगा, induced current हो जाएगा, and it will be according to the Lenz law. ठीक है? So EMF induced in the second coil will be, first of all, flux induces phi 2 is equals to M into I1, which depends on the current in first loop. ठीक है? And this is the simple formula minus M di by. Clear? Now you can arrange the inductor in series and in parallel. So the resistance may the same formula that we follow in the resistance for equivalent resistance in series and parallel, same will be followed in the inductors also. Okay. So thank you so much, guys. If anyone has any kind of doubt, you can ask right now. Otherwise, the lecture is being over. Thank you so much for being attentive and being responsive in the lecture. Bye bye. Take care.